question number 11, a source is moving in a circle of radius 4 meter with constant angular velocity omega is equal to 10 radian per second. If the observer is at a distance 5 meter from the center of circle, then the time interval between maximum and minimum frequency received by the observer. So, the maximum and minimum frequency is observed by the observer at this position when the velocity is tangential and the point O lies on this line, and its frequency is minimum at this position when the velocity is in this direction and point O lie on this line of velocity. So if I drop a perpendicular at these two positions, then this is 4. So by right angle triangle, this separation comes out to be 3. So this angle and this angle is 37 degree. So if the angular velocity is omega and time t is taken from this position to this position, then we can say that omega t is equal to total angle, that is 74 degree, which is converted in radian as divided by 180 into pi. The value of omega is given in the question as 10. So if I substitute the value of omega here and solve, the value of t comes out to be 0.13 second. So option 2 is the correct answer. Let's move to question number 12. In question number 12, a longitudinal wave is represented by this equation. The maximum particle velocity will be 2 times that of the wave velocity. So if I differentiate this equation to get the maximum particle velocity, so that comes out to be x naught into omega, that is 2 pi into n, and this is equal to 2 times of wave velocity, and wave velocity is omega by k, so it comes out to be n into lambda. So from here the value of lambda comes out to be x naught comes out to be pi into x naught. So option 3 is correct. Let's move to question number 13. In question number 13, a particle of mass m is performing simple harmonic motion along line AB with amplitude 2a with center of oscillation as O. At t equal to 0, particle is at point C, which is OC is equal to a, and is moving towards B with velocity √3a by 2. The equation of motion of the particle is. So we know that the equation of SHM is given by x is equal to a, that is 2a, into sine omega t plus phi. So we have to find out what is the value of omega t and what is the value of phi. Initially the particle is at a displacement a from the mean position, so we can say that sine phi is equal to a divided by 2a, so it comes out to be half. So the value of phi is 30 degree or pi by 6. Now we know that v square is equal to omega square into a square minus x square. So a square is 4a square minus x is a, so a square. So from here the value of v is √3a by 2, so its square comes out to be 3a square by 4. So if I solve this equation, the value of omega comes out to be half. So if I substitute here, it comes out to be 2a sine t by 2 plus pi by 6. So if I open this, it comes out to be a into √3 sine t by 2 plus cos t by 2. So option 4 is the correct answer. Let's move to question number 14. In question number 14, the beat frequency observed when two sound waves, this and this, traveling in the same direction interfere is. So the beat frequency f can be written as f2 minus f1. So f2 is 454 divided by 2 pi minus 410 divided by 2 pi. So it is equal to 44 divided by 2 pi, and the value of pi is 22 by 7. So on solving, it comes out to be 7 Hertz. So option 2 is the correct answer. Let's move to question number 15. In question number 15, A police car with a siren of frequency 4 kHz is moving with a uniform velocity 72 km per hour towards a tall building which reflects the sound wave. The speed of sound in air is 320 meter per second. The wavelength of the siren observed by the car driver is. So, the wavelength of the siren observed by the car driver, lambda dash, is equal to lambda naught minus velocity of car, which is v into t, where t can be written as lambda naught divided by speed of sound in air. So I can write in this way, lambda naught into 1 minus v upon vs. So v is the velocity of the police car, that is 72 into 5 by 18. In order to convert it in meter per second, so it comes out to be 20 meter per second, and the value of lambda naught is 320 divided by 4000 hertz into 1 minus 20 divided by 320. So on solving, it comes out to be 75 into 10 raised to the power minus 3 meter, or 75 millimeter. So option 1 is the correct answer. Let's move to question number 16.